Now we are going to start with the topic PLC block diagram or PLC architecture diagrams. Here we have the input module where we connect discrete, analog and resistor types of inputs, switches, relay contact, sensor, feedback voltage, encoders, ADC, etc. and output module having different type of outputs, discrete, relays and lamps, analog type, control voltages, resistor, digital displays, DAC, stepper motors, and this is the power block which is connected to the input module, output module and CPU, memory, programmer, monitor, rack and chassis. Now we will discuss each block in a brief. First, CPU, Central Processing Unit. The CPU, also called processor module. It is the brain of PLC. It controls the functions and sequences of operations of all blocks of PLC. It is responsible for all the arithmetic and logical operations of data as per ladder diagram program instructions. A PLC CPU may have less powerful 8-bit, 16-bit microprocessor like 8085, 8086 or may have high speed. Second block we are going to discuss is the PLC memory. PLC memory is used to store the monitor program, operating system, user, ladder programs, status of input-output devices, pre-assigned values for timers, counters, etc. in binary, 1 or zeros form. The type of solid-state memory chips used in PLCs are RAM, ROM, PROM, EPROM, EEPROM and NOVRAM. PLC memory organization. The solid-state memory within PLC can be divided into two categories. First is the user memory or program file memory. Second is the storage memory or data file memory. First, program file memory. Program file memory contains system program files, main ladder program, interrupt, subroutines and subroutine program files. Now we will discuss each file in a little bit brief. First is the system program file. It contains various system related information and user program information such as processor type, input output configuration, processor file name and password. Second is the main ladder program file. This file contains user programmed instructions defining how the controller is to operate. Next is the subroutine program files. Program files which are accessed according to the subroutine instructions present in the main ladder program file. A large portion of total memory, approximate 75% or more, is occupied by the program file memory. Next is the data file memory or storage memory. It stores the information needed to carry out the user program like the states of discrete input and output devices, the present and accumulated values of counters and timers, numerical values, shift registers and sequencer files, internal input output relay equivalents, etc. Now the next module is the input and output modules. The input-output modules work as an interface between the processor. Input module, output module work as an interface between the processor or CPU and real-world devices. like switches, lamps, contactors, etc. attached to the PLC. These modules divided into three categories. First is the discrete input-output modules, analog input-output modules, resistor input-output modules. First we will discuss discrete input-output modules. These modules are generally capable of handling 4, 8 or 16 on-off type input or outputs per modules. The input and outputs of the modules can be specified as AC only, DC only or AC and DC type along with voltage values for which it is designed. This is a diagram of PLC input module layout. The input module sends the input signals at each of its input terminal and convert these signals into DC level, suitable for next section. Then the input module carries out the isolation of inputs from the CPU with the help of opto-isolator to protect the CPU. CPU scan all the inputs during the input scan and store the result in the input image status word assigned to input modules. This is the PLC output module layout. The PLC output module operate in opposite manner from input image file. Output module have 4, 8 or 16 output terminals for discrete outputs. A signal from the CPU is received by the output module logic during output scan. This signal then goes through an isolation stage to protect the CPU from any voltage surge from output devices back into the PLC. The isolator output is then fed to a switching circuit or an output relay. AC switching is usually done by turning on a triac. The output of the module may be through a relay or a DC or AC output. Next type of modules are analog input and output modules. These modules can receive and provide the analog signals directly and specified accordingly to desired resolution and voltage current range. Analog modules that can directly accept thermocouple inputs for temperature measurements, monitoring are also available. Input module convert analog input into digital with the help of ADC converters, and CPU stores digital data into storage memory. Analog output module receive digital data from CPU and convert it into the analog signal with the help of DAC converter. Third is the resistor input and output modules. These modules transfer 8 or 16 bit of information to and from the PLC. The input-output information is generally in the form of BCD numbers. Now our next block is the programmer and monitor. The programmer, monitor unit allow the engineer or technician to enter, edit, and check the ladder program to be executed. Handheld terminals, industrial terminals, and the personal computers can be used as programming devices. Now next block is power supply. The PLC has two sections of power supplies: internal power supply, external power supply. Internal power supply provide the supply to the CPU module. This section normally requires plus 5 volt and minus 5 volt DC supply and should be highly regulated. External power supply, this section feeds supply to the input-output modules. This section require plus 5 volt, plus 24 volt, plus 120 volt DC as well as AC supplies. Now the last block is racks and chassis. Rack and chassis. In the smaller PLCs, the input and output terminals may be included on the same frame of CPU. What in large PLC systems, the input and output modules are separate units. These input-output modules are placed in groups on racks, and rack are connected to the CPU with appropriate connectors. Rack is usually a metal framework with a printed circuit board, backplane on which PLC input-output modules and processor modules are mounted. The mounting rack provides data path and power connections to the processor and input-output modules through the backplane PCB. These racks can be interconnected to accommodate a large number of input-output modules. The racks are then installed in the chassis. Chassis is a metal frame on which other parts are installed.